Video we're talking about lesson 6-3 for Algebra 1. We're talking about the third way to solve systems of equations. So this is something we've been talking about for a couple days now, about how to solve multiple equations at once. So we started with graphing, where our equations were in slope-intercept form, or we kind of changed them around to where they look like slope-intercept form, and then we plotted them on a graph. What that let us do was see where the two lines cross, and then whatever ordered pair they cross at is our solution. And then previously we talked about substitution, where we got one variable to equal everything else, and then we plugged it into the other equation, allowing us to solve things that weren't in slope-intercept form, or that would be difficult to graph, or maybe their graphs wouldn't line up on a whole number or something like that. And then now we have a third way called elimination, which is going to allow us to do something pretty similar. If you look at the equations on the screen here, they're not very easy to graph right off the bat, and they don't have x equals everything else or y equals everything else. So this is going to be just another option to help us get there. Probably what will end up happening is between substitution and elimination, once you get comfortable with one, you'll probably have a favorite and want to just change the problem around to where it fits that kind of layout each time before you get working on the problem. Okay, so how we would start elimination, or kind of our sign that we want to try elimination, is not only does it not fall nicely into another category, we also want to line up the equations so that we have coefficients that are the same. So if you notice in front of the y's for each one, we have a 10. Doesn't really matter about the sign in front here, the minus or the plus. It works if it's two different signs, or it works if they're the same one. What this lets us do is we can either add the equations together, or we can subtract the equations from each other to simplify, and then we'll be able to find one variable, plug it back in, and find the other, kind of like the end of substitution. So we would need to think to ourselves, negative 10 plus 10 would cause these to cancel, or negative 10 minus 10. Well, if we did negative 10 minus 10, that would give me negative 20. They wouldn't go away. We want these to cancel out so that we just have x's left. If I add the two together, since they're opposite signs, they would cancel out, leaving me with just x, so I'll be able to solve. So if I add everything, those cancel, and I'll kind of write off to the side here. Negative 8x plus 9x would give me a 1x, or just x. I'd have the equal sign still. Negative 14 plus 7 would bring me to negative 7. And then that's our x value. If this would have worked out to something besides 1, let's say like a 7 here, we would have had to divide both sides and solve for x, but I think we're okay with that at this point. So that tells me in the x spot I have a negative 7. Then what I could do is I could take this negative 7 and plug it in for x in either one of these, and then solve for y. So I'm going to use the bottom one because I want to avoid that negative, but either one would work. I would have 9 times negative 7, and then I'm going to have plus 10y still. So plus 10y, then equals 7. Maybe I should have used this one so the negatives cancel. That's all right. 9 times negative 7 is a negative 63. Still going to have plus 10y and equals 7. From here, if I add 63 to both sides, I'm going to end up with 70 on the other side, and then just 10y on the left. And then if I divide both sides by 10, I'm going to end up with y equals, well, 70 divided by 10 is 7. They actually are pretty similar here. One's negative, one's positive. So that would be my ordered pair. So what this tells me is if I were to graph these two equations, this is the point where they would cross. It also tells me that if I plug in this for x, negative 7, into both, and 7 for y into both, it would solve both of them at the same time. Okay, let's look at something like this. So if you notice, I see two 9s here on the same variable. So that's what I'm looking for elimination. This time they have the same sign, so I need to think 9 minus 9 or 9 plus 9 to get those to cancel. Well, if I did 9 plus 9, that'd be 18. That wouldn't go away. But 9 minus 9 would cancel out. So I'm going to use subtraction this time. And I'm going to subtract the entire equations from each other. So negative 8 minus a negative 7. Well, this minus a negative 7 is like I'm adding 7. So that would give me a negative 1x. And remember, you could use calculator if you want. That's totally fine. The y's cancel, equals negative 8 minus a negative. This would be like adding again. Negative 8 plus 16 would give me 8. I do have a negative 1 in front, so I'm going to divide by a negative 1 and get x equals negative 8. So that goes in my first box. And then in my second one, I need to plug in negative 8 into either of these to solve. Let's go with the top one this time. Negative 8 times, instead of x, the x gets replaced with what we just found, another negative 8, plus 9y equals negative 8 again. That seems to be a theme here. This would give me 64. And then if I subtracted 64 from both sides, I'd end up with a negative 72. So I kind of did two steps at once there. I multiplied the negative 8s to get 64, and then I subtracted it away. Still equals 9y. If I divide both sides by 9, I'm going to have y equals negative 72 divided by 9. Man, I need to get the calculator out for that one. I'm rusty right now. Negative 8 again. I should have known. So that one's going to go in the second box. Awesome. So just a couple things. That's basically the same strategy you're going to use throughout, but just to point out a few things. Something like this problem, the x's line up instead. Totally fine. It works the same way. You would subtract everything to get those to cancel. I'd solve for y first. Plug my number back into y. Same process. Let's see if they throw anything different at us. Something like this. This will be the last one we'll talk about, and that's towards the end of this IXL. Notice that we're not doing graphing. They're not in slope-intercept form. This is one where personally I like substitution better. I would probably add that 5y over and get x equals and do substitution. But if you want to try elimination, these don't currently line up with the coefficients right above them. So you have some options to make that happen. You can either take one of the equations and multiply everything in the whole equation by a number. So for example, I could multiply this entire bottom one by 9, and then these would line up. Or I could divide an entire equation by a number and then have them line up that way. So if I divide the entire top one by 9, those would line up too. It's also possible to do that to both. Like I could multiply this by 5 and this by 9 and get 45s, but that would be a little extra work for this one. But just so you know, that is something you're allowed to do in case in the future that's necessary. So because I see all 9s here, I'm going to go with division. However, multiplication is totally fine. If I divide everything in this top equation by 9, what I'll have now, 9 divided by 9 is just 1, so I'm just going to have an x, I'm just going to have a y, and I'm just going to have a 1 left over. Now I have x and x here, or 1x and 1x, meaning if I subtract those, they're going to go away. Oops, my line's not great there. Something like that. So if I subtract here, what's going to happen? The x's cancel now. 1 minus a negative 5, well, that's like adding. 1 plus 5 would give me 6y. And then on the other side, 1 minus 13 would give me a negative 12. If I divide both sides by 6, I'm going to have y equals negative 2. So that's my y value, so I'll make sure that goes in my y spot. Now what I can do is I can take this and plug it into any of these. This top equation is very simple now, so I'm going to plug it into that and see what happens. X plus the y gets replaced with negative 2 equals 1. Well, that's like x minus 2. Why make it harder than it has to be? I could add 2 to both sides and get x equals 3, and then that would give me my ordered pair. That's my solution here. Awesome. Okay, so we'll wrap up there. So this is section 6-3, and that's the third way along with graphing and substitution to solve systems. All right, see you guys.